Hello, linear algebra students. So this is 1.2 video part 2. We said that augmented matrix can be converted into a reduced row echelon form, and it is very easy to solve the systems. So we talked about that you can use decimal matrix calculator in the last video. The other calculator you can use is something called the linear algebra toolkit. So the link is here, but I think if you just Google linear algebra toolkit, you can find it. Yeah, so let's see, do another one, linear algebra toolkit. Yes, linear algebra toolkit has a lot of, okay, this one. So it has a lot of calculator. This is the one that where you can actually just do a row operation calculator. Oh no, this is transform into a row echelon form, and it can transform into reduced row echelon form. Whereas if you do decimal, they only have in the calculator, you can see that they only have reduced row echelon form. They don't have a row echelon form. Okay. Another thing that is good to know is for the decimal calculator, if you are to increase the column of a matrix, say for example, you can only go to 6, I think. You cannot go more than 6. So yeah. So that's why a alternative is essential. Sometimes if you have to deal with big big matrices. So I am going to talk about how you can use the reduced row echelon form of a augmented matrix to solve now. So when a augmented matrix is only in row echelon form, it is only in upper triangular form, so you have to use back substitution. But if it is in reduced row echelon form, RREF, then the solution is in the last column of the system, if the system is consistent. You can also use it to read off infinite solution. So in this video, we'll touch on that. So the first 3 examples that I'm going to do is just to show you how you can do the same thing as what we have done in 1.1, but instead of using hand row elementary row operation, we just go to RREF right away and then write the answer. Okay, so this is a x2 plus 2x2, x1 plus 2x2 equal to 1 like that. So we'll write the augmented matrix 1, 2, 1, negative 3, 2, 5, right? So to solve it, I want to change it into RREF. Use the, I think I'm just going to use the decimal calculator to write down 1, 2, 1, negative 3, 2, 5. If I have, this is the old one, you can say new matrix, and they will have this, and this is only 2 by 2, so you need another column, 1, 2, 1. You can just use a cursor, and then negative 3, 2, 5. Okay, and then I want to do the reduced row echelon, so you can just use the one that you did. So RREFB, it would be 1, 0, negative 1. 1, 0, negative 1, 0, 1, 1. Okay, so you write down 1, 0, negative 1, 0, 1, 1. So what does it mean? This means x1 is equal to negative 1, x2 is equal to 1. So it is all, the answer is here. So, or you can say negative 1, 1. Okay, do a 3 by 3. So this is recorded in the augmented matrix first, 1, 1, 1, 3. There's no coefficient, that means it's 1. 1, negative 2, 4, 5, 0, 3, 4, 2, right? Just record it. And then I think I have it already. 1, 1, 1, 3, 1, negative 2, 4, 5, right? 0, 3, 4, 5. I already enter it in matrix F, and then I do RREFF, and there I have it would be the last column, 5/3, 1/3, and 1. Sometimes when you do REF, it is not a whole number. You might see those decimal like this. You click this, it will show a fraction. Okay, so let's copy the question, the answer back. I don't have enough space, so I would just say the answer is what is it? What is the first? Oh, 5/3 for x1, and then 1/3 and 1. Okay, the last one. 3, -3, 6, 6. 1, -2, -1, 5. 4, -1, 5, 10. So isn't it easier than doing row operation and also back substitution? You just do RREF and you have it. I enter it at 3, -3, 6, 6. Where is it? Here. I enter in G. Okay. You can just keep on saying new matrix and then add columns and enter them. You can also reuse some old matrix. 3, -3, 6, 6. 1, 2. I just want to make sure. Oop, it's a -2. Oh, 1, -2, -1, 5. Oh gosh, I have a. Oh, 1, -2, -1, 5. 4, -1, 5, 10. 4, -1, 5, 10. So I got it in G. So I'm going to do G. Oh gosh. Maybe I think I have a typo here. I want to stay with 2. I think 2 works actually better. So I'm going to change my notes to use a +2. This one probably is a typo, so it's a +2 because the answer is kind of funky. If I do -2, so see how if I do this, I have something like that, and it would be the matrix is 1 0 1 0 0 1 -1 0 0 0 0 1. Now don't look at it as that's the last row is the answer. Why? Because in the last time we have all the 1 1 1 here, so you have x1 x2 x3. The prefix columns are all lined up, right? But in this one I don't have a prefix column in x3. X3 never show up. Okay, the prefix column is only 1 and 2, so there's no mention of x3, so which is not good. And I also can see that there is a row where where is 0 equal to 1, which is a contradiction, right? So I'm gonna go back to here, and I would say this become RREF become 1 0 1 0 0 1 -1 0 and 0 0 0 1. Remember the theorem that say if you have a prefix column in the rightmost column which is non-zero, then this is inconsistent. And you can also say that when you write this back as a system, this is a contradiction. So this is an inconsistent system. So REF can solve equation, can also discover inconsistent if you have a single prefix column in the rightmost column. Okay. So how do I? So this is solving equation. The second problem that we're going to work on is how to write solution of an infinite system. So it's a system that has infinite solutions. So look at this. This is a REF, right? Do you see? This is a prefix column. This is a prefix column, 0, 0, top and bottom. So I can write the solution right away. So, but how do I write it? If I write it back into a solution, what do I get? X1. This is X. This column is for X1. This column is X2. This column is X3. This is B, right? X1 minus 5 X3 equal to 1. And then I have X2 plus X3 is equal to 4. And then the last one is all 0. So it's nothing. It's not contradiction. So it's a consistent system, but I have infinite solution. Why? Because I don't see x1 equal to a number, x2 equal to a number, but I see question like this. So To write a solution, what you would be, this would be the basic variable. We call them the basic variable. This is the pivot column. And x3 would be a free variable. When it is not a prefix column, it's a free variable. So I would write x3 equal to 3. And the solution would be like this. So the first things you do is to translate your RREF into a systems of equation, and then you write a solution as what is x1? x1 would equal to 1 plus 5x3. x2 is equal to 4 minus x3. Oh, and then x3 is 3. So whatever that you put x3 in, you plug it in, you will have x1, 2, 3. So it is an infinite solution. So in some notation, like I think in the my open math, you would write it as 1 plus 5x3, comma, 4 minus x3, and then x3 like that. So, but in this book, this is the general solution. They call it the general solution. So x3 is 3. That means you can put it anything you want. You can make x3 equal to 5, 10, 100. So there's infinitely many. Try another one. So this obviously is not a RREF. So the first step to write a solution is change it into RREF, right? So 3 row and then 1, 2, 3, 4, 5, 6. So there's a lot of time involved in entering it. Did I enter it already? No, here I'd enter it in C. 0, 3, negative 6. No? 0, 3, where is it? Negative 6, 6, 4, negative 5. Just make sure that it is right. 0, negative 7, 8, negative 5, 8, 9. 3, negative 9, 3, negative 9, 12, negative 9, 6, 15. Yeah, look, okay. So this would be a C. So I say RREFC. This is the answer. Oh, gosh. It's too really long. So I have to write it down. 1, 0, negative 2, 3, 0, negative 24. 0, 1, negative 2, 2, 0, negative 7, 0, 0, 0, 0, 4, 0, 1, 4. Write down. Okay. Mm, 1, 0, negative 2. There's a lot of, although you use the calculator, there's a lot of like entering, a lot of work still on entering it. Negative 2, 2, 0, negative 7, 0, 0, 0, 0, 1, 4. Okay, so let's circle the perfect position. This is the first non-zero entry, perfect position. And so we have 2, oh, this is 1, right? So we have 1, 2, 3, three perfect column, and these 2 are free. So x3, x4 are free. x5, x1, and x2 are okay. So let's write it, the solution. X1 minus 2x3 plus x4 equal to negative 24. The second one would be x2, right? x2 minus 2x3 plus 2x4 equal to negative 7. The last one is just x5 is equal to 4. And we don't have 3 and 4. x3 and x4 is free. So that's how you write the general solution. And then to make it nicer, you would have x1 equal negative 24 plus 2x3 minus x4. Basically move this over. So you have like a row of x1, 2, 3, 4 like that. x2 is negative 7 plus 2x3 minus 2x4. Oop. And then x3 now, we put them in order. x3 is free, x4 is free, x5 is 4. So this one is fixed, but all the other would depend on 3 and 4. If you change them, you will have another set of solutions. So you can see that it is the infinite solution. This is how you solve it. We say this is the general solution. That's how they call it. It's called a general solution. Okay, so I'm going to talk about how to determine uniqueness in the next video.